Hey guys, welcome back. This will be, or welcome, sorry. This will be our notes for 9-2, and it's going to be solving quadratics by graphing. So let's just get right into it and start doing all our review stuff. So remember, a quadratic is any equation. It'll show up in this form, and that's a little bit light, so let me rewrite it. It's ax squared plus bx plus c. So this is called standard form. There are other forms that we've seen, but this is standard form. And remember, a, b, and c are just variables. A cannot be 0. Now, we know it's a quadratic because we're dealing with an x squared, and that's the highest power. Now, we're going to talk about a quadratic equation in standard form. Equation just means you have an equal sign in there. So now we're saying equals 0. This is a quadratic equation in standard form. We're dealing with a quadratic in standard, equals 0. Now it's in standard form. So if it was something like, and this is just a preview, so if I had something like negative 7x squared plus 3x minus 10 equals 0, hooray, we're in standard. But if I had something like 3x squared minus 4x equals 10, we are not in standard. So the tips to moving into standard form, you always want the a to be positive. So you look, the x squared is already positive, so I'm going to leave that over here. Now I'm going to bring everything else to the other side by either addition or subtraction. Since it's a positive 10, I will subtract 10 from both sides, and then we end up with 3x squared minus 4x minus 10 equals 0. Now we are in standard form, okay? So that's going to be the first thing we look at. I'm just going to review like one or two more ways and make sure that we can put it into standard form. So I'm just going to jump into what the hardest one might look like. You probably won't even see anything this difficult, but if you can understand this, you got it all. Negative 4x squared plus 2x minus 7 equals 5x plus 3. So I want to get this in standard form. The key is keeping the x squared positive. It doesn't have to be. It does not have to be. You can have a negative x squared, but it's always easier to deal with your a as positive. So when I look at this, okay, my x squared's over here. Well, if I want this to be positive, I'm going to bring everything over to that side, okay? So I'm going to say, if I'm going to bring everything to here over there, I have to do the opposite. Negative 4x squared, I'm going to add 4x squared. And by the way, you can do this in one step or two step. And let me actually do that in red. Maybe that'll show up a little bit better. So I'm going to add 4x squared. That's showing up a little bit better. And then I'm going to subtract 2x. And then I'm going to add 7. Whatever you do to one side, you must do to the other side. So make sure I put my squared there. I'm going to actually line the stuff up. There's no x squareds over here, so I'm going to go really close to this side and put a 4x squared. Now under the 5x minus 2x, under the plus 3 plus 7. You see how everything over here matches over there? Now, all of this would become 0 because that was the whole point of this. You can say the word cancel out. Really what happened is they added a 0. 4x squared, no other like terms, so the 4x squared drops. 5x and negative 2x are like terms, so 5x minus 2x plus 3x, 3 plus 7 plus 10. And now we are in standard form, and because I know some of us got a little left brain, right brain, you might want to bring it over here. And that's fine. Notice I just switched their sides. You're allowed to do that. Excuse me. Okay. So that portion should get you through putting it in standard form. Just remember, get everything on one side, set it equal to 0. Okay. Now we're going to talk about solving by graphing. When you have something in standard form, remember when we talked about doing quadratics? I hope you're picking me up. I apologize. I was talking to you with my back turned. Remember when we were solving quadratics? We said to solve it meant the same thing as the x-intercept, the root. Okay, so all those things mean the same thing. So when we try and solve the equation in standard form, we're looking for when the graph crosses the x-axis. Okay, well, our parabolas can do a couple things. So they can either be pointed up or pointed down. Remember that we said when A is positive, A is negative. We did all that stuff in class and moving our arms around. But let's think about this. Okay, so you can have a typical parabola. I'm going to do it in black so that way it matches up. You have a function that crosses 2 points. So you'd have two answers. Whatever those values are of x would be your answer. Because remember, when you cross the x-axis, y is always 0. So that's the x you would plug in to get a y out of 0. And that works. Now we could have two other scenarios, though. So you could have a graph that just comes down, I'm going to do it in green, and touches in 1 point, right? So if your graph touches in 1 point, you're fine. This green graph, this green function, would have one solution. It's where you cross the x-axis there, okay? Now, one other scenario can happen. What if I had a parabola? I'm going to do the red one way up here. Don't let this start. This is crossing the y-axis, but we don't care about that. I mean, it's an important point, but we don't care about that for our solution. Our solution states, or excuse me, the rule is, the solution to our equation is where the graph crosses the x-axis. Never crosses the x-axis. So what is our solution? No solution. Okay? And that's fine. Some don't have solutions. Sometimes there's no number you can plug in and make 0 come out. And that is fine. That's fine. But you need to be able to recognize these on a graph. Okay? So that is going to be me going through the concepts. And then I'm going to start looking through some of your examples and working through on the next one. So I guess I will do these in clips because it started to take a little bit longer than I wanted. So let's just end this, and then I'll get into the rest of your notes in the next couple. Sometimes this takes a long time. Bye, guys.